name is Priyati Jain, and this is my final project on multi-digit classification and detection with CNN. The workflows that I have followed for developing CNN is first I pre-processed my data, followed by model building, training, and afterwards I perform digit localization in the real images and then its classification. The dataset that I used doesn't have any non-digit samples, that is negative samples. So I generated those non-digit samples using the provided dataset. As you can see in the image, the 19 is cropped out and the remaining part is used as the negative sample. I've ignored the images having more than 4 digits as the number in the dataset was very less. I've used batch size of 32 while training on CPU, and while training on GPU I've used batch size of 128. I used Adam Optimizer because of its adaptive learning rate. To overcome overfitting, dropout layers are added in the network. This is built on TensorFlow with early stopping criteria. I have used two VGG models, one pre-trained and one with the randomly initialized weights, and both have the input 64 cross 64 into 3. This is my designed architecture in which I am using filter size of 5,5 because it represents more high level global information. The output of the architecture is 4 softmax layers, digit 1, digit 2, digit 3 and digit 4. Next comes the digit detection pipeline. For digit localization, I have used MSER plus non-maximal suppression. The result of the algorithm can be seen in this image. Next comes the digit detection phase. Localized regions are cropped. Localized regions obtained via this are cropped into size 64 cross 64 and Gaussian filter is applied to handle the noise before feeding to the trained network. The results of the digit detection phase can be seen in this image. Here it is able to classify all the images correctly. There are few images in the dataset which there are few images, real images that the model is not able to classify correctly. For example, it is not able to identify this 8. It is identifying the alphabet sets digits and it is not able to identify 8 1 in the 801. This is the performance of my network, of the three networks that I have trained. So clearly VGG pre-trained networks have outperformed the performance. Next comes my designed CNN, and VGG from scratch has performed very poorly. These are the model and digit 1 digit model loss and digit 1 accuracy and digit 2 accuracy charts for the three trained models. I am using Goodfellow implementation of CNN over SVH and dataset as my benchmark for this study. They have achieved the testing accuracy of approximately 96%, while my model achieved testing accuracy of 91%, which is really good.